In physics, exotic matter is matter that somehow deviates from normal matter and has exotic properties. A more broad definition of exotic matter is any kind of non-baryonic matter that is not made of baryons, the subatomic particles, such as protons and neutrons, of which the ordinary matter is composed. Exotic mass has been considered a colloquial term for matters such as dark matter, negative mass, or imaginary mass. Types of exotic matter. There are several types of exotic matter. Hypothetical particles that have exotic physical properties that would violate known laws of physics, such as a particle having a negative mass. Hypothetical particles that have not yet been encountered, such as exotic baryons, but whose properties would be within the realm of mainstream physics if found to exist. States of matter that are not commonly encountered, such as Bose-Einstein condensates and quark-gluon plasma, but whose properties are perfectly within the realm of mainstream physics. States of matter that are poorly understood, such as dark matter, ordinary matter placed under high pressure. Negative mass. Negative mass would possess some strange properties, such as accelerating in the direction opposite of applied force. For example, an object with negative inertial mass and positive electric charge would accelerate away from objects with negative charge, and towards objects with positive charge, the opposite of the normal rule that like charges repel and opposite charges attract. This behavior can produce bizarre results. For instance, a gas containing a mixture of positive and negative matter particles will have the positive matter portion increase in temperature without bound. However, the negative matter portion gains negative temperature at the same rate, again balancing out, despite being inconsistent with the expected behavior of normal matter. Negative mass is mathematically consistent and introduces no violation of conservation of momentum or energy. It is used in certain speculative theories, such as on the construction of wormholes and the Alcubierre drive. The closest known real representative of such exotic matter is the region of pseudo-negative pressure density produced by the Casimir effect. Imaginary mass. A hypothetical particle with imaginary rest mass would always travel faster than the speed of light. Such particles are called tachyons. There is no confirmed existence of tachyons. If the rest mass is imaginary, this implies that the denominator is imaginary because the total energy is unobservable and thus must be real. Therefore the quantity under the square root must be negative, which can only happen if V is greater than C. As noted by Gregory Benford et al., special relativity implies that tachyons, if they existed, could be used to communicate backwards in time. Because time travel is considered to be non-physical, tachyons are believed by physicists either to not exist, or else to be incapable of interacting with normal matter. In quantum field theory, imaginary mass would induce tachyon condensation. Materials at high pressure. At high pressure, materials such as NaCl in the presence of an excess of either chlorine or sodium were transformed into compounds forbidden by classical chemistry, such as Na3Cl and NaCl3. Quantum mechanical calculations predict the possibility of other compounds, such as NaCl7, Na3Cl2, Na2Cl, and Na3Cl. The materials are thermodynamically stable at high pressures. Such compounds may exist in natural environments that exist at high pressure, such as the deep ocean or inside planetary cores. The materials have potentially useful properties. For instance, Na3Cl is a two-dimensional metal, made of layers of pure sodium and salt that can conduct electricity. The salt layers act as insulators while the sodium layers act as conductors.